Okay, lesson 2 of this year 9 topic on energy and forces. And today's lesson is energy transfers. If you remember last lesson, we looked at all the different types of energy. We gave some little examples, and then we looked at the two families, how some things are stored as in stores, the energy is inside them, and others are stored in, are pathways. They link the stores together. There are also sources which people always keep fixating on and mentioning. They are not part of what we're doing today. So today is all about how energy can be changed. Now, if we were to take the simplest example we all can understand, take a light bulb. Okay, they don't really look like this much anymore, but I still like drawing them. Then what we can draw is a little diagram of energy changes. So we can show energy going in, and then the energy being changed into two different types. So, going into a light is electricity. I'll call this electrical energy. And I'm going to put 100, forgot to mention the unit, joules. All energy is measured in joules. Doesn't matter what it is, any of those, it's in joules. Okay, so we've got electrical going in, and it would be a pretty lousy light bulb if it didn't do the following. If it didn't make light, so I'm going to put light. But unfortunately, it does something else we don't want it to do. It makes heat. And the reason we don't want it to do that is that's using up the money. If this was £100, then some of that is going to heat, and that's not why you build a light bulb. So if I was to share this energy out between the two, these old light bulbs were about 5 joules, Joules, and about 95 joules. Now I'm just going to put a capital, 95 joules, and when you add them up, you get your 100. And so that shows us something about energy transfers. It shows energy can be changed. Make sure you're copying it down. Can be changed from one type to another. Like that. What else can energy do? Well, we could put that energy, we could have electrical energy again. Ooh. We could have electrical energy again, and this time it could be in a charger. Electrical. And it could go into a battery with a plus and a minus, a little bit at the top. And so energy can be stored. Energy can be stored. And there's one other thing that we can do with energy. And that is, say we have a power station here, and it's giving off all that smoke. So we've got a power station here to electrical lines going across Britain. So we have the pylons for hundreds of miles. And in there is the electrical energy, and it goes to your house. And so energy can also be, that's not a window, that's a door, and those are windows. Energy can also be transferred. So the final bit here is energy can be transferred. It can be transported around. We can put it in batteries to store it, then we can move that around. We can load it into fuel, petrol, diesel, and we can put it in our vehicles and move around. So our 3 key points of what energy can do, I'm going to put them in green. Energy can be changed from one type to another. It can be stored, and it can be transferred. But I want to now give you an example of that change, but something that always does happen. This is called a pendulum. Here we've got the ceiling. We're going to mount on a piece of string with a hook, like so. And I do this in real life. I really wish I was there. We'll put a heavy ball on the end. Now, there's plenty of examples of this on YouTube. There's a couple of videos of people getting hit. They're quite comical, but I don't condone that. And we're going to let the ball go, and the ball's going to go this way, like so. So we've got here an energy transfer of a pendulum. Copy this down. Okay, so what's going on? Well, here at the top, remember you can press pause at any point if I go a bit too fast. At the top, we have gravitational potential energy. And let's give it a number. Let's say it's got 10 joules. What's going to happen to that energy as it moves from high, there it is, high up, down to lower? Well, that gravitational potential energy is going to reduce. It's going to go down. The gravitational potential energy might go down to, let's say, 3. But here's the thing about energy. It cannot disappear. It has to become something else. So what does it become? It becomes kinetic. And it will be about 4. But I hear you say, when you did that example earlier, Mr. White, with the light bulb, you said the 100 was shared out between the 5 and the 95, the light and the heat. The 10 only adds up, 3 and 4 makes 7. Where's the rest? Well, the rest is lost as heat energy, and it will be up here where the little hook, it'll be giving off heat, it'll be rubbing. That might be 2 joules. And as the ball is moving through the air, it's heating up the air. So thermal will be the remaining, I'm doing it in red for bad, the remaining 3 joules. So what happens when the ball swings to the other side? Well, it doesn't swing as high. This is why things always wind down. So if I draw my next ball, it doesn't go as high as the previous time. It doesn't go as high up there, it's lower. So as it moves this way, now, not 10 GPE, it'll only have, say, 7 joules. In fact, it'll have less than that. Let's go 5 joules. Kinetic energy is 0. It's not moving. 0 joules. So we've gone from having 10 to 5 pretty quick. And then as it swings back the other way, again, it's losing it every time as thermal energy. And so it doesn't go as high. Backwards, forwards, until all the energy is transferred into thermal energy. So that's my final statement. As energy changes from one type to another, it loses some as heat. I'll use the word thermal. Both the same as thermal. Eventually, all energy will end as thermal. This is why things need winding up, why batteries run out. Everything ends as thermal energy. Now I've got a nice little example of this. A solar powered water fountain. So the light goes in, let's get yellow, light goes in, it turns into electricity, powers the pump pumps the water up, and the water trickles back down, it goes round and round. So now let's have a look, with all this language that we've learned about energy and energy transfers, let's figure out what's going on. So I'm going to label them, I'll do it in purple. I'm going to label them number 1, number 2, number 3 is the motor, number 4 inside the jug, and going down like that, number 5. So let's have a look. At number 1, we have light energy. What's happening next? Number 2, it's changing into number 2, electrical energy. Number 3, I'm going to run out of space. I'm going to shrink this in a bit. It's turning that electrical energy into kinetic energy. The motor is spinning. Okay, so we've gone light goes in to a solar panel. Not heat, light. It is changed into electrical energy in the wire. The wire then gets the electrical energy changes into kinetic energy. That spins the pump around. The motor goes spinning the pump. Okay, let me shrink my writing so I can fit the rest in. Try that again. Try it again. Oh, messed that up. There we go. So shrink it. There we go. What's going on next? It goes up to the jug. So number 4. I like those lines straight. Number 4. It becomes GPE because it's up off the ground. So that's where the energy has now gone into GPE. And finally, as it moves down, it's going to make 3 types of energy as it moves. So number 5, I'll write separate here. Number 5, it's going to be kinetic energy as it moves, but it's also going to be making sound energy, and it's also going to be making thermal energy. And that is the process by which the energy moves. Any questions, put them in the comments. Bye.